Let's see if I can figure this out. Just gonna see if I can optimize the control tasks here a little bit. Much work to be done on this. Gym.acquire. Oh wait, hold on. Let's see if I can figure this thing out. One. Did he use my code for this, or did he use the original? Hmm. Okay, so he kind of did a mix of both. Where does this come from? Wait, you didn't call. Okay, wait, you call refresh here. I had this. I had this set up. See, but now I don't even want to mess with it because let me look at the observation at least. I don't want to have a chance that, well, I guess we'll see if the train curves match the original. So we will be able to verify. Let me see. Difference between... Yeah, so clean PufferLib is just like, that's gonna have all the clean RL style code. Demos just a wrapper around it that passes all the arguments so that you can load in whatever env you want, and it lets you run sweeps and stuff like that. So yes, you can use the demo file to run all of the Ocean M's out of the box, and yes, it supports continuous actions as well. Also, since apparently Google's linking people the wrong docs, it's right here. We have a full walkthrough. It's hopefully all up to date as well. What is this? Compute humanoid. Cheers. Yeah, no worries. See, now I'm worried about this because this doesn't look like it relativizes the data correctly. Damn it. Yeah, this is a tough position to be in here. Might be better to just straight up wait for Kyung and work on my other stuff in the meantime. And just know that I'm going to have to allocate a big block of time to this once he's ready. I think that's what we're going to do. So I'll just spend like an hour now on the hypertram stuff maybe. Let me try that. Just kind of tired today. Let me see if we can still figure out and make some progress here. It's just the last couple of days of work have been pretty intensive. And it's been a pretty deep dive into a lot of these things. Let me see what produced this graph, right? Oops. Okay, so this one versus this one. Okay, this is not divided by cost. This one is divided by cost. Let me think about why this is. So unnormalized poor mean. Unnormalized nearest Pareto score. Is this what we got? Yes. So you subtract out the score here. And multiply the distance to the nearest Pareto. I think I need to make the cost estimate conservative. I think that's the problem. And do some logging here. Having all these transforms is really obnoxious. I don't know why we're working in log space anyways here. How do I do this? Do you just X the variance? Okay, this is obnoxious. I see why they wanted to just get these transforms from somewhere. The sklearn ones are not very good. And this is apparently because Gaussian processes. This is so screwy. None of this data is freaking normally distributed. Maybe the input variables are, but the outputs definitely are not. I know what I can do. There's a trick. There is a trick. Normalized log cost mean. We'll just do, watch this. This is a trick. Normalized conservative costs. And I hate these variable names. I'm gonna redo this at some point. And then, did I do this correctly? No, this should be plus. And I want to also change the prints here. We can tell what's going on. So we're going to do, this is going to be predicted. So this is going to be then will be score will be a normalized score mean. Oh no, wait, best. This is still, Let's do this. Score nearby. Then let's see, this one is going to be unnormalized score mean. This is going to be unnormalized nearest Pareto score. Nearby. Okay. It still goes straight to 200. Let's see, so we have score, nearby, here's your distance, and there's the predicted cost. So it actually gets this pretty much correct, but it says that this is the best you can do here. Okay, so it's got to be I think it's my math that's screwy, not the algorithm here. Let me think about this. We're going to do some freaking grade school, like pre-high school math is what we're going to do here. People messaging me. Deleted. Weird. Okay, so we're going to make a new one of these. This one, thank you. And okay, so say you have a point here. Okay? And then this point's here, and this is 200 and 200. Then this formula, unnormalized formula, this prediction, nearest Pareto. So this is 200 minus 0 times 200 divided by 200. Okay, so now we see the problem. These go away, and you still have 200. So if there's no point to the right, this is going to incentivize you to do crazy things. If we make everything conservative, is it going to help? It really screwed up performance in the old model, but the old model had terrible Gaussian processes. Let me think. Well, first of all, how's this doing? Yeah, you see it got away from it quicker actually. But it started with some very high cost experiments. Is just making the score oops, conservative, normalized. And then this is going to be minus. Score standard deviation. So next thing we can do conservative unnormalized score mean. We'll see what this does. Because you start sampling, your random samples are seeded in okay, I think I know how this works. So this is what you would want. You would want both of these quantities to be conservative. Because everything else is pulling you to high cost exploration. This is what pulls you away from it. So this is what guards you against a bad model. Now the problem is that in the old version of this algorithm, before I messed with it, they had really bad Gaussian processes. And using a conservative estimate, it depends on your Gaussian processes actually getting good. Because if your Gaussian processes are bad and do not generalize, then it'll just prevent you from ever exploring anything. So hopefully now this is okay. Do you need to relu this? You might need to relu this actually. We'll see if something weird happens. It's nice. Okay, so here, so this is what we had before. Is that a bit better? About the same. Okay, so making the cost estimate conservative. It's apparently not enough. It seems like it helped prevent. No, you see, we still have all these points at 200. This is what we're trying to prevent right now. So we're going to try this next. We're not going to run the whole thing. We're just going to watch the first few samples. 200 cost. 100 cost. Okay, it only did one bad sample. Oh, there's another one. Nope, still taking bad samples. Let me look at this though, because this says something. Let's fix one thing first. Try again. Okay, this distance is still wrong. Let me see why. Oh wait, this is nearby. Maybe not. It's crazy that the cost estimate is that screwy. How is this the case? Let me see. That looks good. That adds like a good amount of uncertainty. I should be taking square root even, shouldn't I? Square root of variance. So I'm literally adding this squared standard deviation. And it's still not enough. Which is an insane thing to do. I just forgot to take square root. I'm getting to be very skeptical here. Is this the kernel? Hang on, is this the kernel? There's literally like 1 point at 200. Variance grows quadratically. Distance from the origin? Ew. I'm trying to figure out if the problem I'm having is an expected problem or if this is weird. So you can see right here, right? Score. This is a pessimistic score calculation. There's just a lot of error, even with a pessimistic. The variance should be huge. And this is with a whole bunch of points to start as well, random trials, which you're not going to have. Let me think about this. See, the problem with these sample-based metrics, right? The problem with this you're not necessarily rewarding good samples. You're rewarding samples outside of the support. This like there are two sources. Well, let me think. Are there multiple sources of error here? No, the model should just be good within its support. how about this? Let me see this rating. I'm trying to figure out what it is he sees. Okay, so this point of 200 got assigned a rating of 3 because the cost prediction, conservative cost mean, was 28. You can see I didn't get any high points here. So you can see it was 28, but the actual was 200. See if I can catch one of these live. Okay. Holy. 7. Okay, it predicts a cost of 31. It says that it's going to score 54. The nearest point, Pareto point, is at 23. Can that be the case? $54. At cost of 31. Does anything score higher than 54 at 31? Nope. 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 Okay, so that is a Pareto point. They say the nearest Pareto point is at 23. Which gets a score of 23.29. Which gets a score of 23. So does anything get a score better than this? Doesn't 47 at 51? Cost is 30. It's going to be cost less than 31. Okay, I buy that. Yeah, I buy that this is a Pareto point, and this is the nearest one. And then it says the distance to the next Pareto point is 7. So that's going to be what, like 61? Should be like 61. I'm see a 61. Wait, is it 61? No, I'm dumb. Hold on. 30. Should be like 40 cost. Oh. Let me make sure I get this right. Oh wait, so that's 41. Hold on, wait, what? No, 30, 38, 39. Here it is. This gets a score of 32. What the other one? 23? So yeah. Okay, so I buy that these distance calcs are correct. And it says it's going to get a score of 54. So I know based on this problem, this is impossible. The optimal score is equal to cost. And this is supposed to be Yeah, so this is the pessimistic one as well. Because you can see here, the unnormalized one says 72. But the variance is way, way too low. It has no business being this confident. This is in fact the main reason we use these models. Length scale might be too short. Okay, so this is possible. Predicting a cost of 14. Okay, that is substantially reduced. So let me see. So unnormalized core mean says this, and then the cost mean. So this is a horrible prediction. Okay, this is actually better. Do you have any tips for starting a new project? I struggle. Um, Try just copying the template and editing from there. Gives you all the boilerplate. I mean, ideally what you want is you want to be able to be in a spot where your projects just don't require hardly any boilerplate, and then you won't have that annoying block. I've tried working to get the boilerplate down, but it's kind of tough with the Python to C to like with the Python intermediary. Like if you want to build a new env, like just go copy squared. In this case specifically, it's probably that. And other stuff like you should kind of be excited to start a new project because you don't have any of your old garbage code to deal with. Like most of the stuff I do, I look at it and I'm like, I have no idea how I'm going to do this, but I'm confident I'll figure it out. And it's like I have the exact set of skills required to figure this thing out, so I am going to figure it out. Including this thing right here. It's getting a rating of 3 because it's underestimating the cost by a factor of 2. I should probably plot confidence. This is tricky in a way because I don't think I can penalize if I divide by the variance. That really penalizes. But statistically, that doesn't make any bloody sense to divide your prediction by the variance. I can see what happens for the hell of it. It's knowing that it's all normed like this. I'm curious just to see what this does. Still, you get an immediate 200. Look at this. That's crazy. Because then, let me see, it's going to be score minus nearby. They get like 35. Well, they say the freaking cost is 15 when it's 200. So it rates high because they're so wrong. It's just rates the most wrong predictions. Damn it. And I don't know why they have the same variance. Wait, are these all the bad predictions? Hang on. Yeah. Let me run it a little longer. I think what's happening is we're just selecting for the worst predictions. Okay, so now it's learned. Now it is learned. And the variance is way lower. You know, I wonder. I wonder. Let me try something here. I wonder what happens. Oh, didn't do it. Hold on. Does this start you with a good model? Right. Gaussian processes don't like it when you have a lot of points, do they? They really don't seem to like it when you have a lot of points. Holy. There we go. Why is the cost rating still bad? Hang on, that doesn't make sense. I gave it 200 points. We have 400 just to be sure, 300 just to be sure. There's pretty decent coverage, at least at the lower end here. It's completely wrong. Yeah, completely wrong. Okay. We gotta figure out why the model is this far off. Okay, this works. See if it still works. Yes, this still works, and it works nearly perfectly. Okay, so now $250. First 200 being random. Here's what we're going to do. The last 50 points. You have an accurate model. What does this give you? How are we doing today? It's going. It's so many different sources of error in this thing, man. A lot of sources of potential error. This looks better, not perfect, but better. We'll see how this ends up looking. To go for dinner in a second. But I'd like to at least have some idea if this is decent. I think this will be a more fruitful approach, is to first assume that you have good Gaussian processes, get the algorithm to work, get it to work on the various different synthetic problems, then figure out how to make sure that it doesn't do weird, like run expensive experiments too early while it's still fitting. There's your first cost 200. Well, look at that. I mean, that's pretty good. It's definitely an improvement. It even goes back and runs some lower cost experiments. They're nicely spaced. We don't like it running high cost experiments like this and getting them wrong. These ones. It looks like it had just misfit this line a little bit. Hey Joseph, what's good? About to go for dinner, but I've been working on hyperparam sweep. There's so many different versions of this thing. We managed to get a hyperparameter sweep to do this. I mean, my health is what it is. It's going to take 6 months to get back in proper shape. I ran 5 miles yesterday, so I'm like, I can function. But, you know, like before this, it could have been 15 miles. This is very funny. So I had an original formula that managed to like pick a bunch of different Pareto points and then kind of like slide down starting from the individual points, like there, 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 and there. We got this one's jank. This is better, but this is like, again, there's too much over here going on. This shouldn't be here. This shouldn't be here. And now this is better. Maybe a standing desk. No, I'm gonna be comfortable while I'm working and do real exercise. Right? I run and I power lift. What's the command to compile the PyX? This. Yeah, I've got a nice comfortable chair here, thank you very much. I'd rather just get my exercise in. And I ran, so like the reason I'm still here um, is because I ran 1,500 miles last year, as well as hit 1,000 total. So I basically did like exercise as a part-time job doing all that. And I mean, that saved me. So I take it very seriously, but I also don't want to hurt myself too early. So I'm not running every day yet. Um, we'll get that back soon though. Yeah, there you go. I have my barbells coming on Wednesday. The rack's going to take a little longer, but at least I can start doing some RDLs, some overhead press, some bent rows, stuff like that. I don't know, maybe I'll rig something so I can at least bench a little bit. We'll see. Isn't that supposed to spit out? Yeah, it will, but you don't have to touch that file. The only thing that you have to do in order to get this to get picked up by Python is it? Just add your robocode like right there or somewhere. All right, all you have to do is add it as an extension, and then it'll spit out your robocode file. And then you should just be able to import it from Python. You know, wait, I realized there's a problem with this, the way I did this. There's still a problem. Last one, and then I'm going for dinner. See if this did anything better. 200, 30, 50. Versus up here. Yep, okay. That'll give you a better model. Just need to clean up Python. Yep. That ought to work for you. Okay, so now, hey, how you doing? Working on some hyperparameter sweep stuff. It's tough because there's so many different sources of error that are not explicitly accounted for that you have to think about here. I'm actually getting suspicious as to whether the Gaussian processes are really going to be able to do everything on their own or not. Because they seem to really underreport their error. So to be fair, I guess what I'll probably do is I'll fix this, then I'll go figure out why they underreport their error. I'll correct for that. It's very weird. Well, that looks like it works pretty well if you have a perfect model. Fills this in very nicely. I said last one, but this one will be very quick. RL's coming back at us fast. What do you say the best way to apply RL to circuits would be? How can I treat the circuits? There was a company that I was considering, or that was considering hiring Puffer for this. They do that. Yeah. You just have to make a simulator and make it fast. Is the main thing. You define your reward, you define your action space, placing chips. You have to make your sims very fast. That's the key to everything. Not perfect yet. It almost should be like, no, I mean, it has the perfect model. In fact, you know what I might do? I might literally give it a perfect model because it should be doing binary search. Like the perfect model case, it should be doing binary search. That actually would be very elegant. Okay, I like that idea. I gotta go get food. I may or may not stream after dinner. We will see. I will definitely be back tomorrow, though, working on stuff. Thanks, folks, for tuning in. If you're interested in following any of my stuff here, this is all free and open source. If you want to help us out for free, just start the repository. Really helps us out. You can join the Discord to get involved with development, or if you want some assistance in using Puffer. We've got all sorts of fun demos right here on the Ocean tab. Everything from as simple as Breakout, as complex as this MOBA, Neural MMO, and other sims. If you're looking to read a bit more about cutting edge RL or learn RL if you're new, we've got a bunch of blog posts for both of those. And if you want even more content, there are some articles on my X that you cannot find anywhere else, as well as a bunch of RL related posts. Let me answer this question and then sign out here. Board layout is nice. The technical physics-based stuff, applications related to Pharma Science and Fusion Center at MIT, part of a company that I'm trying to get going. I mean, if you have a serious application, then yeah, like message me on the Discord, because we work with startups as well. If you're trying to do something there. I'd have to see like what type of thing you're trying to learn and whether it's feasible to write a fast sim for it. Generally, where RL is at the moment, you want to be in a space where whatever the problem is you're trying to solve, ideally you can have a fast sim for it. So I can look at that and see if that is feasible with the techniques that we use. Yeah, thank you. Yeah, we're pretty good with I mean, I really like working with startups. So yeah, we have some good terms there potentially, and only if it makes sense, of course, for what you're trying to do. But anyways, thanks.